Welcome to a journey of endless curiosity in 108 Questions of Why. Welcome to a journey of endless curiosity in 108 Questions of Why. Clouds, those ethereal formations that drift across the sky, have long fascinated humanity with their ever-changing shapes and sizes. From the fluffy, cotton-like cumulus to the wispy, delicate cirrus, clouds are not just mere vapors. They are intricate manifestations of the atmosphere's dynamics. To understand why clouds have different shapes, one must delve into the science of meteorology, the physical processes of water vapor, and the environmental factors that contribute to their formation. At the most fundamental level, clouds are composed of tiny water droplets or ice crystals suspended in the air. These droplets form when water vapor in the atmosphere cools and condenses around tiny particles known as cloud condensation nuclei. The process begins with the evaporation of water from oceans, lakes, and rivers, turning liquid water into vapor that rises into the atmosphere. As this vapor ascends, it encounters cooler temperatures, which cause it to condense back into liquid or solid forms, creating clouds. The shape of these clouds depends on several factors, including temperature, humidity, wind patterns, and the presence of atmospheric disturbances. One of the primary reasons clouds exhibit different shapes is the varying atmospheric conditions in which they form. For instance, cumulus clouds, often characterized by their puffy white appearance, typically form in conditions of rising air. As warm air rises, it expands and cools, leading to condensation and the development of these billowy formations. The shape of cumulus clouds is influenced by the strength of the updrafts that create them. Stronger updrafts can lead to taller, more towering cumulus clouds, while weaker updrafts result in smaller, flatter formations. Their characteristic cotton-like appearance is a direct result of the turbulent air currents that shape them as they grow. In contrast, cirrus clouds present a completely different visage. These high-altitude clouds are composed of ice crystals and often appear as thin, wispy strands stretching across the sky. Their formation occurs in the upper troposphere, where temperatures are significantly colder. Cirrus clouds typically form when moisture-laden air rises rapidly, leading to the sublimation of water vapor into ice crystals. The high altitude and low temperature contribute to their delicate, feathery appearance. The wind patterns at these altitudes play a crucial role in shaping cirrus clouds, as strong, upper-level winds can stretch and thin them into long, graceful streaks. The ethereal quality of cirrus clouds often evokes a sense of calm and tranquility, contrasting sharply with the more robust cumulus formations. Stratus clouds, on the other hand, embody a different character altogether. These low-lying clouds form in layers, creating a uniform gray blanket that can obscure the sun. Their formation is typically associated with stable atmospheric conditions, where moist air is trapped near the surface. Stratus clouds lack the vertical development seen in cumulus clouds, and their flat, sheet-like appearance results from the gradual lifting of moisture-laden air over a large area. This horizontal spread gives stratus clouds their characteristic uniformity, often leading to overcast skies and persistent drizzle. The lack of turbulence in the atmosphere contributes to their smooth, even shapes, creating a stark contrast to the more dynamic cumulus and cirrus clouds. Another fascinating aspect of cloud shapes is their relationship with weather systems. Fronts, which are boundaries between different air masses, can dramatically influence cloud formation and shape. When a warm air mass meets a cold air mass, the warm air rises over the colder air, leading to the development of nimbostratus clouds. These thick, dark clouds are associated with steady precipitation and can cover large areas, creating a dull gray sky. The shape of nimbostratus clouds is determined by the stability of the atmosphere and the amount of moisture present. Unlike cumulus clouds, which can develop rapidly and show great vertical growth, nimbostratus clouds tend to spread horizontally, resulting in a more uniform appearance. The influence of wind cannot be understated when considering cloud shapes. Wind shear, which refers to the change in wind speed and direction with altitude, can lead to the formation of unique cloud structures. For example, lenticular clouds, which resemble saucers or UFOs, form when moist air flows over mountains or other topographical features. As the air rises and cools, it condenses into these distinctive lens-shaped clouds. The shape of lenticular clouds is determined by the wind patterns around the obstacle, creating a striking visual that often captures the imagination of onlookers. These clouds can appear stationary, even as the air flows continuously around them, highlighting the dynamic interplay between wind and cloud formation. Furthermore, the presence of atmospheric instabilities can lead to the development of more dramatic cloud shapes. Cumulonimbus clouds, towering giants of the cloud world, are a prime example. These clouds are associated with thunderstorms and severe weather, characterized by their anvil-shaped tops that can reach heights of over 60,000 feet. The formation of cumulonimbus clouds occurs when warm, moist air rises rapidly in an unstable atmosphere, creating strong updrafts that allow the cloud to grow vertically. The shape of these clouds is a direct reflection of the intense convection taking place within them, leading to their towering, imposing presence. Cumulonimbus clouds can evolve rapidly, transforming from fluffy cumulus to a formidable storm cloud in a matter of minutes, showcasing the dynamic nature of the atmosphere. As clouds evolve and change shape, they also reflect the underlying processes occurring in the atmosphere. The interaction between temperature, humidity, and wind creates a complex tapestry of cloud formations that can tell us much about the weather. For instance, the presence of cirrus clouds often indicates that a change in weather is on the horizon. These high-altitude clouds can signal an approaching warm front, as they typically precede the more substantial cloud formations associated with precipitation. Similarly, the presence of cumulus clouds can indicate fair weather, while the development of cumulonimbus clouds may herald thunderstorms and severe weather conditions. The shapes of clouds are not merely aesthetic phenomena. They serve as indicators of atmospheric processes and weather patterns. Observing the clouds can provide valuable insights into the state of the atmosphere, allowing meteorologists and weather enthusiasts alike to interpret the skies. The art of cloud watching, a pastime enjoyed by many, involves recognizing different cloud types and understanding their implications for weather. From the fluffy cumulus clouds that suggest fair weather to the ominous cumulonimbus clouds that signal storms, the shapes of clouds offer a window into the dynamic nature of our atmosphere. In addition to their meteorological significance, clouds have inspired countless artists, poets, and dreamers throughout history. Their ever-changing forms evoke emotions and provoke thoughts, serving as a canvas for imagination. The soft, billowy shapes of cumulus clouds may inspire feelings of tranquility and joy, while the dark, brooding presence of storm clouds can evoke a sense of foreboding. The interplay of light and shadow on clouds creates a visual spectacle that has captivated artists and photographers, leading to stunning depictions of the sky in various forms of art. Clouds also play a crucial role in the Earth's climate system. They influence the planet's energy balance by reflecting sunlight back into space and trapping heat in the atmosphere. The varying shapes and types of clouds contribute to this complex interplay, affecting weather patterns and climate on both local and global scales. Understanding the relationship between cloud formation and climate is essential for predicting future changes in our environment, particularly in the face of climate change. In conclusion, the diverse shapes of clouds are a testament to the intricate interplay of atmospheric processes. From the fluffy cumulus to the wispy cirrus, each cloud type reflects specific conditions in the atmosphere, shaped by temperature, humidity, wind patterns, and atmospheric disturbances. The dynamic nature of clouds not only provides insights into weather patterns, but also serves as a source of inspiration for artists and dreamers alike. As we gaze up at the sky, we are reminded of the beauty and complexity of the natural world, where even the simplest of phenomena, like clouds, can reveal the profound intricacies of our atmosphere.